Hello, I'm Seth Kessler, President and CEO of the Metis Design Corporation. This Tech Talk will provide a high-level summary of our NAVAIR SBIR project, developing an embedded structural health monitoring system for gearbox components. Metis Design is a small technical consulting firm located in Boston, Massachusetts. We specialize in structural health monitoring technologies in nano-engineered multifunctional assemblies. We have experience from more than 24 Phase 2 SBIR efforts, many of which have resulted in successful commercializations, including technology licenses to Tier 1 suppliers and spin-off companies. One of the core components of the system being described today was licensed for manufacture to UTC Aerospace Systems in 2016, now part of Raytheon Technologies. To ensure safe operation of their rotorcraft fleet, the Navy requires accurate means for detecting fatigue cracks longer than 50 thousandths of an inch on gearbox splines and assuring all bolts have been fastened to within 5% of their specified torque levels. Since there is no redundancy for gearbox on rotorcraft, longer cracks or lower torque values can quickly lead to catastrophic failure. Presently, gearbox need to be disassembled for manual inspection in an often multi-day process that is one of the most costly preventative maintenance items for the Black Hawk fleet. Therefore, we have developed an in-situ structural health monitoring approach for gearbox assemblies. Ultrasonic transducers and digital electronics are packaged into a robust washer that can be integrated within the gearbox itself to inspect for fatigue cracks and measure bolt torque deviations. A circular array of piezoelectric transducers are placed in contact with the face of the gear around its perimeter using a dry couplant material in order to scan the part as a beamformer to detect and isolate changes in ultrasonic wave propagation. A prototype of this system was integrated into a tail gearbox received from Sikorsky that had a known service-induced crack through a spline. Using our system, we were able to correctly identify the location and extent of that service-induced crack, as illustrated by the unwrapped gear image seen in this slide. The colors indicate number of standards of deviation the resulting ultrasonic signal has changed over a baseline undamaged measurement. This system is roughly at a TRL and MRL of 5, having been tested on a real Black Hawk tail gearbox in addition to a series of representative fatigue specimens. As previously mentioned, the core hardware for this system is already manufactured by Raytheon Technologies and has passed airworthiness standards. New components have been designed using the same design guidelines. We also have developed an exciting wireless data and power transfer option with analog devices that would be compatible with this system and has already been approved by the Navy and Air Force cybersecurity experts. In summary, this embedded gearbox structural health monitoring system is capable of capturing both fatigue crack initiation and reduced bolt torque without any need for disassembly or manual inspection. Data can be collected on the ground in minutes and does not require the helicopter to be powered. The result will be enhanced safety through more frequent non-invasive inspections and better asset availability without the need for tearbound inspections. We are seeking additional programs of record who might be interested in exploring this SHM technology for gearboxes on other rotorcraft or even naval vessels. Specific to Black Hawk, we will be seeking additional testing opportunities beyond this program for qualification on spin stand and eventual flight testing. Again, I thank you for your attention, and please contact me directly if you'd like further information about this novel gearbox SHM technology.